Hi, Ryan Cleckner with Gun University. I'm a former special operations sniper and sniper instructor, and I'm the best-selling author of the Long Range Shooting Handbook. And in this video, I want to talk to you about shooting at angles, what it does to your bullet's impact, and how we can compensate for it when you find those situations out in the real world. Well, first, shooting at angles doesn't matter whether you're shooting up or down. The calculation and the effect on your bullet is going to be the same. Simplest summary I can give you right now: if you don't want to watch the rest of this, if you don't want to see the trigonometry that goes into it, and you don't really want to know how to calculate it, I'm just going to give you a secret now. Your bullet's going to impact high. If you're shooting uphill or you're shooting downhill, your bullet is going to hit higher than you expected it to, so you need to aim low. If it's not too far away and it's not too much of an angle, aim a little bit low. If it's a big angle and it's really far away, aim a lot low. Now, I know you're watching this though because you're into shooting long range, you're into precision shooting, and just aiming low is not going to be enough for you. But it is a great thing to remember when you're hunting and you need to make a quick shot. I'm not doing the calculation. If I have a monster bull come out in front of me and I'm about to shoot and it's at an angle, I'm just going to remember to aim a little bit low. But let's talk about the math that not only lets you compensate for it exactly, but also helps you understand what's going on and why this phenomenon happens. So let's assume we're sitting here on a hill, and you're up here, and you're shooting downhill at a target down here. You can get the true distance to that target, let's say with a laser rangefinder. The true distance to the target is actually, if I were to run a measuring tape or that laser rangefinder and measure all the way to the target. That is not what we are going to use to shoot the target, however. We're going to use what I like to call the angle distance. So remember the difference. True distance is actual. Angle distance is what we're going to figure out doing some math, and that's the distance we're going to use instead and pretend that it is that shorter angle distance away. Now to do this math, we're going to realize that if we make a line straight down for the height and a line straight across for the distance, well, if that's a right angle, we can make a triangle out of this. This side of the triangle, if you guys remember any trigonometry or geometry, on a right angle, this is called the hypotenuse. That hypotenuse, that side of the triangle, is our true distance to the target. I want us to figure out, however, this distance to the target. That is what we're going to call our angle distance, and we're going to pretend that the target is only that far away. Now, a way I like to think of this isn't really what's happening, but the way I like to think of this is, the bullet is only covering that distance across the surface of the earth. It's only covering that much, for gravity, and so therefore gravity is only going to affect it that much. Again, scientifically that's not what's happening, but I like to think about it that way. I hope you can see that if I took this true distance and collapsed it down, it would be longer than that angle distance. So the angle distance is always going to be shorter than the true distance, which is why the bullet impacts high, because the bullet is pretending, or it's flying, it's not pretending, bullets can't pretend. The bullet is flying as if it was only covering that distance. Let's do some math and see some numbers, and I'll show you how it works. The first thing you need to figure out besides the true distance, so let's call this the second thing you need to figure out, is the angle at which you're shooting off of level. Again, this works up or down, but for now I need to figure out what angle down I am shooting at that target. Now, another thing, if you remember geometry, is if this is a right triangle, we can make a completely mirror image triangle and all the angles are the same. So when I'm figuring out this angle, I'm also figuring out this angle. That matters because we're going to go way back to trigonometry, and this is a part that for some of you that don't want to know the actual trig behind it, and you're just like, Ryan, tell me the numbers and tell me how to do it. This is your clue to skip ahead in the video just a little bit. But for the rest of you that want to see the actual math and understand how it's working, check this out. Do you guys remember the mnemonic SOHCAHTOA? We were taught this in high school trigonometry, if we ever did that, and it refers to sine, cosine, and tangent. We're going to be using these things to figure out our angles here. And what this stands for is if you have the opposite and hypotenuse, you use sine. If you have the adjacent line and hypotenuse, you use cosine. Well, this is the one we're going to use. We're going to use cosine because if I know this distance, let's just say this is 1,000 yards to make it nice and easy. I know my hypotenuse, and I'm trying to figure out the adjacent line to that angle. So since I have hypotenuse, and I'm trying to figure out the adjacent line, I'm going to use cosine. So I take the cosine of whatever this angle is, I multiply it times the true distance to get my angle distance. So it's cosine times the true distance equals the angle distance. The cosine is figured out either on a scientific calculator, on your phone. I have the table listed out in my book. You can write it down in your dope book. This is something you should keep with you. This is not something I ever expect you to memorize. And it doesn't matter a whole lot at small angles. We're going to treat this like it was 30 degrees for this example. And guys, 30 degrees in the real world is not as common as you think. Whenever I have sniper students up on a hill and we start an angle class, one of the first things I do is we look down at the targets and I ask the group to estimate what angle they think that target is from level. And everyone stands here and does kind of this and goes, that's about 45 degrees. And it ends up being about 20 degrees, okay? Mountains and hills, if you've ever noticed, all tend to have a pretty consistent angle to them if you look at a mountain range. Or if you drive by a construction site and you see piles of dirt, have you ever noticed the piles all have the same angle? That's that natural angle that dirt sloughs off on its own. Here's another scientific term. It's called the angle of repose. Forget I said that. I'm embarrassed I said that. It is the angle at which it sloughs off. It's about 30 degrees. So usually the steepest you're ever going to see in nature is 30 degrees. To get even 45 degrees, there's going to be a cliff or something super steep somewhere. So we're going to go with 30 degrees, which is about the most you're going to find in nature. And I already know that the cosine, I'll give you a few examples here. I know that the cosine for 30 degrees is 0.866. So I take the cosine for 30, I multiply it times the true distance, and I get my angle distance. Well, 0.866 times 1,000 is 866. So my angle distance is 866 yards. When I'm shooting down at 30 degrees, I'm going to treat the target as if it is only 866 yards away when it comes to gravity. So I'm going to look at my dope book. I'm going to put my dope on for 866 yards. I'm going to shoot that target that's actually 1,000 yards away from me. I'm going to hit exactly where I'm aiming because I properly accounted for the angle. As you can see, if I didn't do this, if I shot an 866-yard target with my 1,000-yard dope because I didn't account for the angle, I would impact high. That's why it happens. If we come closer or less of an angle, the change isn't that much. So for example, the cosine for 5 degrees is 0.999. So if you're shooting 100 yards away and it's a 5-degree angle, it's really going to be 99.9 yards away. You can't really account for that. It's not much of a difference. The cosine for 10 degrees is 0.984. 45 degrees is 0.707. So it gets more and more of an effect the bigger you go. I'm not going to say at a certain angle or a certain distance it doesn't matter. It always matters, even if it's slight. Just whether you account for it or what you do about it is going to have an effect. So you're out hunting, 100 yards away, 200 yards away, 20-ish degree angle or less, just aim low. If you have the time and you're shooting long range and you have a way to find the angle and you have a great way to find the distance, you can do this calculation to figure out your angle distance. Now, a couple important things. I said you shoot the angle distance when it comes to gravity for your elevation. You do not use the angle distance when it comes to wind. So if you're calculating the wind, even though we are treating it like it's only 866 yards of drop for the elevation, the bullet is still flying all 1,000 yards to the target, so it's exposed to wind for the entire 1,000 yards and for the amount of time it normally takes that bullet to travel 1,000 yards. So you need to compensate for the wind based off of the true distance. Another thing to remember is you got to know the angle. How do you find the angle? Well, modern rangefinders now have this and take all this out of it. You can put in the settings of a rangefinder to calculate the angle distance for you, and that's the math it's doing. You can use a smartphone. Most smartphones have an app that will tell you the level, and you can just take the edge of the phone and look down the edge of the phone at the target and see what the reading is. It's also handy to look through the rifle and put the smartphone right on top of the scope cap when you're looking at the target, and it will tell you what angle you're looking at. Or if you have devices like a Mil-Dot Master, or you can even make one on your own dope book where you have a hole in the corner, you can tie some fishing string and a little weight, and by holding it on the edge, you can watch the string hang and you can read the angle right there. So having a method to get the true distance, having a method to get the angle, understanding the concept and the math involved on why we're going to get that shorter true distance, or angle distance, forgive me, and remembering to do wind for the full distance, you're set. Get out there, find some angles, and put it to work.